thank you so much for tuning in to our second installment of our AMA. This time the theme is our Move programming language. FYI, this is actually going to be a bi-weekly basis. So every other week you'll have a different theme, and then every other week you'll have Move programming. So really happy to introduce our lovely guests. So I'm Jen. I lead up social here at Mysten. And here today we have Todd and Damir. If you guys could introduce yourselves, please, and share a fun fact.
Yeah, my name is Todd. I've been working on Move since 2018. I did the compiler stuff, source language stuff. These days a bit more focused on Sui integration work, other Sui related things, still doing some compiler-y stuff, but it has stabilized a bit, which is good. And a fun fact, I guess, I've been at Mysten for, I don't know if it wanted to be a work-related fun fact, but I guess it will be. I've been at Mysten since March. In a fun way, I guess this is only the second company I've ever worked at, so I was at, well, at least full-time. I was at Facebook or Meta for 8 years before this, so it's been fun at the startup space. I've been enjoying it. Oddly relaxing in comparison to what was going on at DM. So.
I actually have an answer to that. It's my 10th company or 12th company. So yeah, I've been in startup business for a while now, and I'm Damir. Trying to present myself as the Move guy, but usually just the second Move guy. I've been coding and using Move since 2019 when these folks at Novi at Facebook were just developing the language. I have been through the first phase of Move IR and then started using Move. And before they have written any documentation for the language, I wrote the book about the language. And then they wrote the book. And now we have 2 books. But the one you see first in Google is mine, and we'll do something about it, definitely.
So before we dive into the first question, if we do have time, please contribute to the event chat panel, because we'll be monitoring that for any additional questions that you might have, especially as either Todd or Damir answer questions, you might have additional ones that pop up. So without any further ado, we'll dive into our first question. So what is the history of Move, and what sets it apart from other programming languages like Solidity?
I'll start here, and Damir can kind of fill in. So, as far as history, my Move was created as the programming language for the Libra and then DM project at Meta. The idea behind, it was needed as a smart contract language, and Sam can eventually come in and correct me if I get anything wrong here. But the idea was, the Meta was looking at languages and trying to find something that they thought would be appropriate for the project, and nothing really kind of fit the bill. There are other smart contract programming languages out there. For a long time, Move has actually tried to avoid the term smart contract. I think we're embracing it a little bit more now on Sui. When we're looking at all these other programming languages, or the other blockchain programming languages, namely for Solidity, it looks like other programming languages, right? It doesn't have assets or other blockchain items as sort of first class items in the language. In some ways looks like JavaScript, and you do these things with maps or mappings, and you're trying to build up programming your value in that way, but it doesn't really have an asset first programming model. So, or built into the language as a first class citizen. So that's really where Move kind of got started, was looking at, these ideas from linear logic or from, linear programming, linear type systems, and using those as a way of introducing scarcity into a programming language. And that's what Move really is. It's a language for programming with scarcity. So when we're looking at languages, okay, we want to make sure that you have this kind of built-in notion of, here are some values. These values represent real-world assets. You shouldn't be able to copy them, and you want to make sure that they're used correctly. So looking into getting into those to other languages, it's sometimes doable, but it's really tricky to then get everything you want. So the kind of big, I think, points when we're looking at blockchain languages that we're thinking about is we need this idea of scarcity, of programming and making sure that the assets you have aren't copyable, that you're using them like you would use money, and they behave like physical money. And then also things that you need for a blockchain language, like metering. It's important if you come onto these platforms, you have to kind of pay for play or pay for the computation that you're using, and just having some mechanism for that. So while you could maybe take an existing language and trying to add scarcity to it, or adding an API for kind of programming with assets, it's difficult to then also get metering. And then I would say even more difficult on top of that is determinism. When you're in a blockchain environment, you need all of the nodes that agree on the result of the computation. Given the same input, you want the same output. And that's what we mean by determinism. And that's also pretty tricky in other languages, right? So if you just take Rust or something off the shelf, you'll have to start really going through and banning a lot of libraries for non-deterministic behavior, like random number generation, as just one example. So, we're looking at all these things, and that's really where Move got started. It's let's just make a really simple language that has all of these things as the starting point of the primitives in the language. So Move really started out as a very, very simple language for programming with resources or assets, and we've kind of added a bit of complexity over time. That's sort of the history of it and why we didn't really take an off-the-shelf language like Solidity or even Rust. I could talk more about the progression of the language if you would like, and that was really just why the language was created. Damir, if you have any kind of thoughts.
No, you go with the history because I was only watching and you were there.
Right, we started with this simple language, and Move had a lot of churn in kind of its core design in the early days. It's first an object-oriented language, and then we kind of adopted the more ML module system. A lot of it was really designed with making sure all of these things for blockchain applications were simple. And from day one, another thing was important was being able to actually have strong guarantees and being able to prove things about Move programs statically. So we always had this goal in mind of building the Move prover and some form of static verification. Because a lot of times when you come back and you want to do static verification on a language, you have to deal with all this nastiness that the language added for expressivity, but isn't really amenable to easy static verification. So originally, Move wasn't even Turing complete. We didn't have general loops or recursion, and the idea was that we were hoping that would make static verification easier. It turned out that we really didn't need that, and it was a bit of overkill. But one thing that we did keep kind of out of the language was dynamic dispatch, or sort of kind of more traditional thinking about object-oriented languages, or even other languages that kind of look like Move with Rust. There's no trace or anything, right? There's no way of having indirect calls or functions where the behavior of what code path or what logic you're taking is really purely dynamic in that way. And this just makes certain parts of verification a lot easier. And while you do have to program in a different way, we think that trade-off is worth it. So the language just kind of evolved from that standpoint. We didn't really have generics at first in the language. There was no sort of polymorphism. That came later. If you're ever bored, you can just kind of go through and read through the VM or the IR. There's a lot of really funly named artifacts, if you will, in there. Kind of a fun archaeology there. Move didn't really have vectors or other collection types at first, and we have this byte array type that was used everywhere. So I think there's still some references to byte array in the code base, which is always amusing. I think that in terms of some other history stuff, I think that one of the things I'm proudest of is the reference safety checks. So we have this borrow checker. Rust is very famous for having this borrow checker that's this static verification around references and produces extremely confusing errors. And I'm not saying that the errors that come out of Move are never confusing, but I think that in terms of the complexity of the system, we've produced something that has similar levels of expressiveness for the reference safety, while being, at least in terms of the formalism or the implementation, much, much simpler.
I cannot, the side view of things back in 2019 or something. We were developing a blockchain which was supposed to be a DeFi blockchain, and we had to choose a language. And at the time, you only had Solidity. The only two options were two upcoming, in developing languages, one of which was Move, and another one was, if I'm not mistaken, Cadence by guys who create CryptoKitties on Flow or something. And Move first was a super bulky, hardly usable language because it was at the moment Move IR, but it already had a number of properties and number of ideas that actually drove me crazy. And a few months later, I completely fell in love with the language, and it was its expressibility. I come from Solidity background, and in Solidity, you express stuff. Who owns something? I own NFT1, you own NFT2. It's a centralized hash map. It's a database. You feel it as a database. You need to re-implement the database. But in Move, you could really own a type. So whenever I say there is a bag of coins, literally a coin, I own the type. And it's not written somewhere in the centralized hash map, but I literally own it. And since I now don't think it's a hash map, centralized something, and now I think with types in my head, I know that if I pass this type coin somewhere. That means that I'm literally taking coin from me and passing it somewhere else. And this idea, once you get it, it's like it opens a lot of possibilities in like move programming in general. So once you start thinking like with objects and not thinking like with abstractions that you build over like not simple but programming primitives or programming constructions like a hash map or like a set or something. Once you start thinking with like if you own a coin, that it is a coin, and if you pass it in a function, then you literally take your coin from you, pass it elsewhere. If it's not a coin, if it's like an NFT, or if it's a coin plus NFT, you always know what you're doing. And this like unlimited expressivity with explicit stating of types was and still is, I believe, the selling point of Move, because you can express anything like you would do in real life. Whenever I'm in a bar and I say like there is this Move language, I tell them, so here is this bottle and here is this glass. Just imagine both of them are NFT, and if we have a function which like pour water or like a beer from this bottle to a glass, you literally pass these two together, the function does it and returns you the full glass. I mean, that's just crazy.
It's been fun having you, Damir's kind of been here along the way for the language. I'm always glad to hear, the sort of things we set out to do were picked up by people at the time. Because, when you're writing this and kind of just like in closed doors at Meta, you're always kind of wondering, people understand what we're doing, people get it, so it's always nice to hear.
Two people who got it.
At least, I guess, yeah.
There's also another question that often comes up. Why did we select to do variants of Move for Sui as opposed to using the standard Move language?
I guess just a bit of background here about, how Move is set up. One of the goals, right, was to build a blockchain language, or not even really a blockchain language, right? Sorry. It's purely a language for scarcity. There's not a lot of blockchain primitives or other things built into the language, right? If you go look at Solidity, it is a language purely for Ethereum, right? Like there's all these things baked in about various like there's the Ethereum, native things that are a core part of the language. And our goal was to make sure that Move felt like it could be instantiated on any sort of blockchain or any sort of application where you wanted scarcity. But we needed a way, right, to generalize storage, right? It's helpful for blockchains if you're able to commit to state or actually write something down, and you're not just making the CPUs hot. You want to, not just spending gas. You want to make sure that you're able to commit to a ledger or, make a change to the state. So Move had this idea of this type-driven global storage so that modules can declare resources with types and then index those into the chain and be like, okay, I'm going to take my coin type and I'm going to move it and assign it to this or give it to this address. So we kind of have this big old map where you have accounts and each account resources and you can have one resource per type. So that was, I guess, kind of the goal of having a generalization around blockchain storage. But when it came to Sui, one thing that we wanted to do was we're trying to make a more efficient blockchain by recognizing that not every transaction is related, and that actually having this big centralized global state is a drawback, and it's a drawback that's not always, it doesn't actually buy you much. If I'm sending a coin to Damir, the blockchain doesn't need to wait around for me to also send some other coin to Jen or to someone else, or someone in chat. I wanted to send everyone in the audience, right, a coin. Like, these are independent transactions. But Move, with the way that it was representing global storage, these sort of concepts were very difficult to express, if not impossible, because it was designed as a centralized account-based model. So to do this differently, we had to kind of like think back of how do we represent individual objects in Move? Like how do we take this sort of independence of data and insert it into the language? And I wasn't there for exactly the design of this, but early in the stages of the design of Move, we thought about having all of the global storage, instead of being this thing that you kind of access through these built-in functions. We were thinking about it as like maybe this would be a parameter that you pass into functions. You have like a storage type that you're passing around in the language. That's basically the kind of concept that we went back to for Sui Move, and that, okay, instead of having centralized data as a part of a primitive in the language, you will instead pass in the objects you want to consume to the entry point functions so that you explicitly say, okay, I'm going to take an object of this type, and then on the transaction level, you specify which object of that type you want, so you have the ID for it. So really that normal Move is just like not set up to be able to represent objects of this. And so what we've done is really just remove the global storage, these big general centralized storage from the language for Sui, and instead gone to this individual object model. So that this is really the way that, or why we kind of needed it apart from standard Move and the thing we're doing differently. Now that being said, I just want to make it clear, it's not like we forked the language or anything. Move was built to allow individual adapters, as we call them, that is individual instantiations of the language, can add these sorts of things by interfacing with the VM without having to actually fork the language or do anything different. So, we're still using the same standard library as other Move instantiations. It's the same VM, it's the same Move lang that we're contributing to upstream. We've just taken a different approach for how we're going to interface with storage.
So you mentioned entry points. It's a bit enough up, but do you know why everyone bailed on transaction as scripts?
Yeah, so I can talk about, I guess, going back to the history there a little bit. One of the ideas for, Move is that if you look at Solidity, it's really not like programming in a normal programming language, right? There's no sharing of code. If you're programming in Rust and you want to go like pull in some other crate, or programming in Java, you can just import like some library or something. It doesn't really exist in Solidity, at least not in like the classical sense, right? You have to copy paste in code or like pull in all these things. Like sure, you can like call out to other contracts, but it's not really like linking against code in the sort of normal way. So what the goals for the Move module system is to behave like more like a normal module system that you'd expect from other programming languages. So that if you want to reuse code on chain, you can do that without having to republish it. Now, the question was then, how do we actually start transactions? So basically have a separation of, you have modules, which is the code, the reusable code. And then a script is just like, I want to, execute this series of instructions on the blockchain. They grew and grew over time to the point where they were really looking like little mini modules. And as such, we've kind of transitioned a bit more into, instead of having necessarily maybe scripts as like, here's a set of instructions, please execute them on chain. Instead in a module, you can say like, okay, here is like a transaction, right? Or here's like an entry point to execution. You can call this function in this module. You can kind of think about it as a reusable script, right? A set of instructions published on chain that you can execute over and over again, as opposed to scripts, which were these throwaway, collection of instructions. Yeah, that's kind of where that's come from. It's really been helpful in terms of programming in Sui for getting these kind of objects, because now the module can define how you can program over the objects.
But we still have scripts, right? I mean, somewhere.
Different language. Yeah, I kind of want to deprecate them. That's a bit off topic here, but we can talk about that later.
I don't know if I should TLDR. So in Move, you could write a program, and this program would be a transaction. So usually you call like a specific method, like the whole program, and publish it as a transaction. So it's like you published your whole program, and it's done its job. So like enter like 100 addresses, and it will split your coin into like 100 pieces, and you write it as code in Move, and it sends to this 100 addresses. And it was like a really cool feature which no one had, and now we don't have it too.
It's a bit tricky because the idea was, the hope was that you wouldn't have to like publish this code, but the script still kind of has to live on chain somewhere, right? And that like you need to be able to commit yourself to this execution and have some replay for it. We're kind of off topic at this point now.
Pardon.
That's a feature of normal Move too. It's not like we are treating entry points to transactions a little bit differently as we move, but we're committing these changes upstream, and the whole entry point story has changed a bit recently for even core Move, not just for Sui.
We also have another question. So for the Move language for smart contracts on the Sui blockchain, like how does the smart contract actually work?
Yeah, so it's a little bit different for Sui. So as I was saying, you have these modules, right, and Move. I really hate the term smart contract for what it's worth. I think it's a stupid term. It's really like marketing around the idea of like programs. In Solidity, it's this kind of like, I have a singleton object or a singleton set of code that no one else can use, and here are some functions you can call into it. And in some ways, the most similar it is to any other kind of existing notion, at least as far as Ethereum works. It's kind of like an actor model, and in a little way, it's kind of like a microservice model. I just like find the term smart contract a bit, I don't know. It's just clever marketing. There's nothing like smart about it. There's nothing really contracty about it. It's just a program. But that's my own personal opinion. I do know that people like the term. As far as modules are in Sui, I was saying that we set out to like do something a little different and Move, having these reusable modules of code. We do kind of publish them in a way that's a bit more similar to smart contracts on Ethereum than in normal Move in Sui. So if you want to write like a smart contract, you take a group of modules and you publish them as what we call a package. package in Sui. So you collect up your modules, you can link against other modules existing on chain, and then you publish those into your account, and you'll get some ID for that. So you kind of have an object that contains, as I was saying, in Sui you have these objects for coins and other assets. And these objects don't have to be just move values, they can also be move code. So you take all these things and you package them up, and now you have an object representing package. That's kind of how we're structuring these things. But anyone can kind of call into it and link to it from their own code. You don't have to kind of do these delegate functions out to a different contract. It behaves a bit more similarly to how you might expect code to work if you're writing like Python or Rust or Java. If there's anything, Damir, you want to say, maybe you're a bit more well-versed in the Ethereum space, if you want to maybe kind of go from there about how it's similar and different.
Yeah, my Ethereum knowledge is like outdated, but you got it right. I mean, usually we try to write code as generic as possible, so it is as reusable as possible. So like, if we have a coin module, which you can see, and we're slowly shifting to the next question, which is about interfaces. If you look at our like Sui framework, you see that we have coin, but it's like a generic coin T, which anyone can use to implement their coin. If you again compare it to Solidity, usually you publish, as Todd correctly mentioned, that when you want to publish something like a smart contract, you usually need to implement everything from scratch. If you have like ERC20 standard, you have this like approve, transfer, like etc. 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 Everything is described in an interface, and you have to implement this interface. You need to code everything yourself. It is a good thing and a bad thing. While following this interface, you don't necessarily have to implement them in a standard way. You can have the transfer method that just licks all your money from you, takes all your money from you whenever you want to transfer something. That is a problem of interfaces in general. I love how Move addresses this problem because we have generic implementations for any type T, and if you look at our coin module, to like make another ERC20 like, I don't like to compare us to Solidity, but anyway, if you want to publish a coin or a token, you just publish one line, which is the name of your token, and it will be your ERC20 like coin on Sui. And then you automatically get all the methods like burn, mint, transfer, etc., etc. And all the solutions we have in Move are pretty much generic, and it improves code reusability, and that's like one of the greatest features of the language as well. You know, even in our like examples can be like easily modified. If you have a sandwich example and you like combine bread and butter or something, you can make a generic combinator module which will combine like two modules somehow. I mean, we can figure out the way to do it. John, do you mind if I just like read the question that I have and that I'm answering?
Go ahead.
Yeah, so we're being asked is if we need like interfaces and standards and Move, like ERC 721 or the new one. And so, yeah, it is not necessary to have them, and we don't have interfaces. And it is actually a great thing because for OpenSea to exist, or like for anything to exist, I mean, first of all, everything is an object. So if you just want everything to be like transferable or like spendable, etc., etc., you just define your type with like a set of predefined abilities and you allow it to be transferred. And that's it. So like my NFT, like Damir NFT, like Todd's NFT, two different types, but they can share the same properties, and they, speaking like in Solidity terms, they implement the same interface. Someone wants to build an OpenSea something. We don't have to follow the same standard as ERC 721. We can have like everything custom metadata, custom ways to combine NFTs, custom ways to burn them, but the like generic OpenSea-like marketplace will be able to work with all of them if we just specify correct abilities on these types. And so, yeah, we don't need interfaces. Everything is generic almost by default, and everything can be tuned, like these slight modifications on like how the type behaves, is how you define abilities for this type. They affect the way this type can be used.
So going a bit deeper into what Damir is saying, the interfaces are a crutch for the fact that you can't really reuse code. And there's no way of kind of customizing existing code, right? So you want to define a token on Solidity. It's like, well, I can't reuse the other existing token code. There's no like token library. So you're stuck trying to adhere to this interface. It's the only solution you have. In Move, the idea is that you write the coin type once and you're done. So there's like a coin module, and this describes the behavior of a coin. You have a coin asset, a type representing the coin, and then you have functionality over the coin that's going to be the same for all coins, right? Where you have splitting, and transferring, combining, and drawings. Now, when you want to come along and define your own token type, you can instantiate the coin type using generics and fill in the inner bits of the coin and saying, okay, I have a coin of, Sui, or a coin of ETH, or a coin of Todd nickels, or whatever it is whatever fantasy money you want to make up on chain. You can just make a new module, make a new type, and then instantiate the coin type with your kind of new token type, and now it's going to work everywhere that coins work. So if you have something like OpenSea where, you want to have transferring of these things, you could imagine having a generic type for coin, or like you could have a generic wrapper for OpenSea NFT, that way the OpenSea can kind of like this is what I expect to have. You can encapsulate your data in that type, and then it'd be good to go. So it's kind of like the most straightforward connection to how things work in Solidity, but we can do things a bit better here, I would say, in Move. That's kind of what Damir was talking about with these abilities for the types. You can define your own type, your own NFT, and it actually doesn't have to use these kind of wrappers that I was just talking about. You can just do whatever you want. And then if you have certain abilities, then the transferring of the Sui object is just going to work generically across the board. That we have this generalized, transfer object. You can invoke a transaction to just transfer the object, and you're done. But you don't even need that. You don't have to have this like public transfer. You can say, I want all code and all transferring to flow through my module. I want tight control of this behavior. And it'd still be easy enough for OpenSea or some other like marketplace to expose this functionality. It might not be like super pretty, but what you can do is you can look at the module and say, hey, I have an object of this type. Let's look for all the entry point functions in this module that use that type. And you can say, okay, here are all the functions exposed in this module for this type. And you could even say, oh, I actually want to call this other entry point in some other function. And I can imagine something like OpenSea or some other explorer or, marketplace having a way of like saying, okay, I want to go look at this module and I want to use the object I have stored in maybe in an exchange or something, and I want to use it with this custom logic. Just because we don't have interfaces, right, doesn't mean there's like not a way of doing custom code too, I think is my point.
I can add to that. Actually, we have interfaces, and we discovered them like a month ago. Yes, that is true. We still discover new patterns. We still discover new ways of expressing stuff. And if you go to like our main branch on GitHub, you go to examples, there is this regulated coin example, and it showcases that we kind of can have interfaces. So like if you want to have this type, you need to implement a module that implements all of the methods of this type. I mean, it is technically an interface. It does allow you to implement your custom type, custom interface. I mean, implement the interface and be usable kind of as the type you're implementing. But on the other hand, you lose this property of like generic ability. So you can't reuse this type, like we have a regular coin example, as a different coin because they're different types. So always better to go with like generic ready to go solutions. But if you want to see like how interfaces are implemented, then check out our regular coin example. I doubt anyone will ever use it, but maybe there will be someone.
And on top of all of that, what do you think are the disadvantages of the Move programming language?
Yeah, I think we're kind of hitting into some of them in an interesting way. There's like disadvantages of like things I'm unhappy about, and like, oh my god, why did we never get around to adding XYZ feature? There's still some like basic stuff missing from the language, or at least what I view as missing. I consider that a disadvantage. But maybe a better answer to this is that most languages that you program with have some form of indirect calls, right? You have like some form of indirection. If you're programming in Rust, you have a trait. If you're programming in Java, you have like various interfaces or other things you can do, and we just don't have that. There's no dynamic dispatch. There's no indirect calls. What you see is what you get in your module. This is a feature. You get really strong guarantees about your code, and you're able to prove things about your code that you wouldn't otherwise be able to prove formally. The downside is you have to kind of think differently about how you're laying out your code. The coin module is great, but if you were working in another language, you just probably wouldn't set up the code that way. The amount of expressivity is similar. It's just a bit different in the way and the programming patterns you have to use. So I would say that the disadvantage here is that in order to get kind of this power of these strong guarantees, you have to program a little bit differently. But I think about it, as kind of like driving on the other side of the road, right? Like in the UK, they drive on the left side of the road versus in the US, we're driving on the right. And they both work. It's just that your muscle memory in terms of driving is probably going to be a little different. And you're going to have moments where you're going to like freak out, like, oh my God, I'm driving on the wrong side of the road. But, you just kind of have to sit back and reassure yourself that, you're still going to be able to get to where you want to go, be a little bit more careful, and think a little bit differently than how you might have before.
We have one punch that is always there, like one punch line. People come and say, how would you implement a DNS in Move? And our answer to that is that we will never implement it because we don't need to. But the actual problem that people usually ask is that in places like Solidity, because Solidity is like a reference smart contract language for everyone, and it will change, but for now it is like it is. So in Solidity, you can have like a hash map, a central hash map that says like this IP address is this domain name and vice versa. And so you can go to a single place and check a lot of data in a hash map. It was addressed as like one of the main problems of Move because you can't have a centralized storage because it's going to be super expensive. Move will lose all of its properties and will become like extremely slow. And write sets, I mean like the change that you will do will affect the whole hash map because like Move write sets usually rewrite all the data you have stored. So if you had like 1 million records and you changed one or added one, you will have to rewrite 1,000,001 records again. So correct me if I'm wrong, but that's how I always treated it. The DNS problem is something that we haven't solved. I mean, solved like in a direct way, but you can always find a way to implement it. Like Todd said, you need to change your mindset, you need to change your paradigm. You can always store like a bunch of objects. It won't be as programmable as you are usually used to, like go there, like use hashmap get something, as a result get like the address or the name of the like website. But it will be something different and it might require more like off-chain tooling. But in the end, you will have more efficient, more scalable, possibly like a bit more tooling, of course, but we try to not have huge storages, huge centralized storages of data on the chain because it is not good, it is not effective, and Move makes most of the profits of decentralization where all assets are spread on different addresses and you don't put everything together. So if you have any comments on this, please.
It's a great example for exactly the sort of like behavior pattern I was talking about. And that most commonly the kind of questions we get are like, I did this in Solidity. How do I do this in Move? And the answer is you don't, but you don't need to. And you should be laying out your code differently. Like you're not centralizing all of the entries for your NFTs in a single map. Instead, you have individual NFT objects. And just the kind of downstream effects of those decisions mean you just have to think a little bit differently about how you're programming. Like, okay, I should be programming on like a kind of per asset style and not thinking about how would I do this with being able to view the entire world at once, right? So it's just a little different.
I love that like response. We don't, or you don't. We do it differently. We need to remember that.
What do you think about privacy?
I saw this question and I'm not entirely sure which direction they're coming about. Yeah.
There's ways to interpret it, right? We better see it as a way of what are the capabilities of privacy that you can lay over Move as a language? Are there limitations of privacy that you can enact on Move? I mean, I would say like those are probably pretty good starting points.
I would say that you wouldn't expect some privacy from the language. You would assume it like, I just spent like last year working in AZK at Alio, and you wouldn't expect it from the language. You would expect it from the backend because like MoveVM produces bytecode, and this bytecode is something that can be produced in plain. It can be encoded somewhere else, and you can use MoveVM like inside some platform which will like transform the resulting bytecode into a ZK circuit which no one will ever read if they don't have like a proven key and verifying key. And so it is not a problem of the language, and I doubt it should be treated this way because we can always encode some data off-chain and pass it into Move and then do something with it and then like return the same encoded data, but it will be private because no one knew what was coming in and what is coming out. I mean, people know what was coming out, but they also know what happened to this initial data, but they don't know like what the initial data was. On the other hand, if we just take the MoveVM and like how private is bytecode, I would say that I'm slowly shifting this topic into elsewhere. It is less private than Solidity because Move bytecode is cleaner, it's more decodable, it's more usable, and like overall better if you're like a developer working with this bytecode. I mean, compared to Solidity, of course, because we do comparisons today. It's our game. Because with Solidity, if you get like a contract API, you usually cannot treat it because it's encoded in this like weird way. You have lots of different versions of compiler. Of course, there are probably like some Solidity compilers, but usually you treat Solidity bytecode as something like obfuscated, which you will never get. While with Move, and you can also see it in our Explorer, like each program gets sort of decompiled. I mean, partially, not fully. You can always see the method signatures, you can always see the types. And so everything that happens with Move is kind of like transparent. You can check everything that's going on, even the bytecode.
Yeah, so let me kind of hop in there. And I think there's like just everything you talked about, Damir. There's some stuff about like kind of more cryptographical privacy, which I don't really have any opinions about. And it's not like Move is like set up to handle that. You're exactly right. Thing you might be doing outside of the language, or maybe we could have like some native functions or something for various signature schemes or whatever. But in terms about like the actual like understanding the actual bytecode, it's a lot more understandable and readable, and you look at the bytecode and it's the same for everyone. One of the goals for Move was that the bytecode language would be, we have the strong guarantees at the bytecode level. There's a type system for the bytecode. That all of your asset and scarcity rules that ensure your objects or your types are being handled like they would for money, these guarantees are checked at the bytecode level. So, anyone could like write a programming language for the bytecode and get the same guarantees, or they'd be tied to having the same guarantees. They can't like somehow say, okay, if I write a different source language that compiles the Move bytecode, you can't sidestep these sort of guarantees. And when we're talking about this, as Damir was saying about being able to view everything and all the like signatures, functions and stuff that are stored on-chain at the bytecode level, we refer to this, as like sort of a secure compilation pipeline. So that when we're thinking about Move programs as the source language, and a different source language can make a different choice, but language doesn't add any abstractions that aren't really present at the bytecode layer. Now, that's not saying there aren't like features there aren't, like testing, and there's some annotations and approver specifications. These only exist at the source language level. But when we're talking about the signatures of functions, they're exactly the same at the bytecode level. And this is really important because it means that any of the guarantees you have at the source language are present at the bytecode level, so that anything someone can do, the source language is going to give you some error. So if you're trying to do something illegal or incorrect with the type, you want to make sure that that behavior is still present at the bytecode level. Maybe a better way of saying this is that you don't gain expressivity by trying to interact with the bytecode directly. That's really what we're talking about with secure compilation, kind of having the same level of guarantees down the pipeline. So I just think that was an important, just the thing to bring up when we're talking about like viewing the bytecode on chain, is it's not like you're able to like somehow sidestep the rules of the language or sidestep the behavior that a module writer or contract writer, if you will, intended for their types once the code was published on chain.
So Move offers a unique feature for NFTs, but is there anything that it does in a unique way for DeFi that other languages don't offer?
I know we're running short on time, so maybe we could try to answer this really briefly. But I would say almost in the way that the type system doesn't do anything unique for NFTs. It does something unique for assets, and it just turns out that NFTs are like a really non-interesting, from a technical standpoint, a really simple and almost non-interesting instantiation of just like having rules where things behave like real world items. Damir, I don't know if you have anything else to add quickly about this.
It just provides security guarantees for everything you hold. It provides this like inability for someone to like take your assets, to modify your state, like to take something from you. So you're like always safe if you own something and if you interact with something. If you have like an LP token, and we're working on Uniswap example, you can look in our like pull request. We'll soon have a pool, a typical AMA stuff. Is it called? Yeah, automatic market makers. So you have security guarantees, but the only problem you might have faced there is that the highest like integer that we support is U128. We're thinking towards like adding support for U156, but that's like a huge question whether we actually need it or not. But apart from that, you get everything you need. You can work with math, you can work safely with assets, and lastly, with Sui, you can do it like in a decentralized manner, and you can do a lot of stuff faster with like higher transaction throughput and with lots of transactions at the same second.
So mindful of time, I know that we have additional questions. Please keep them coming because in another 2 weeks we will be doing our bi-weekly AMA specifically around the Move language. So whatever questions we have that we couldn't get to, we will definitely be consolidating it for the next round. So please look forward to that in the coming Thursdays. And thank you so much, Damir and Todd, for taking the time to walk us through some of the questions that our lovely community had. So we'll continue to keep this going every Thursday. And if people have feedback, please share on the events chat. We're always looking to improve our AMA experience for everybody who dialed in. Thank you. Have a lovely evening, morning, afternoon, wherever you are.